I'm going to go over the rest of the practice exam 1 that we weren't able to finish in class. So we went over everything up to number 23. So number 24 is asking for the range of the sample data. The range is equal to the max minus the minimum, which is the entire range of our data. So we need to find our maximum, which is 2,496, minus our minimum. Our minimum is 1,266. So over here, we have a difference of 1,230. So our range is $1,230. Moving on to the next question, number 25. It's asking for the standard deviation for the given sample data, and it says round your answer to one more decimal place than is present in the original data. So we're going to have one decimal in our rounding. So in order to find the standard deviation, we want to enter this into a list. We're going to enter it into list 1. So if there's data in your list, you're going to have to clear it out by going to the top, go clear down. Now we can put in numbers. So 40 is our first number, then 20, 31, 21, 12, 55, 75. Always check your numbers afterwards. We're going to go to Stat, Calc, 1var Stats. We have our data in list 1. We're going to clear out the frequency list because we don't have a frequency list. And then we hit enter. So here's our 1var Stats for our list 1. And our mean is equal to 36.3. And our standard deviation is equal to 22.3. And it's only asking for the standard deviation, so here is our answer, rounded to one decimal, and I will also put it up here. Number 26, again, is asking for the standard deviation, but this time we have a frequency distribution. We have the classes over here, which are the scores, or the ranges of scores, and then the frequencies over here. In order to input this in the calculator, we need to find a value that's representative for each class, and we're going to use the midpoints, which are the points right in the middle. So that's the first thing we have to calculate. In order to find the first midpoint, we're going to do 50 plus 59 divided by 2, which is 54.5. The next midpoint is 60 plus 69 divided by 2, and that is 64.5. The next one is 70 plus 79 divided by 2, which is 74.5. And hopefully you notice a pattern over here. Our class width is 10, and you can also see that in the difference of the midpoints. So the next midpoint would be 84.5 and then 94.5. So we now put our midpoints into list 1. We're going to put our frequencies into list 2. And then we're going to find the 1var Stats. Our data is in L1, and our frequencies will be in L2. So let's go back to Stat and edit in order to put in those lists. So we're going to first have to clear out both list 1 and list 2. List 1 has the midpoint, so 54.5. So you can say basically your data is in list 1. The numbers that are representative for each one of these categories is in list 1. 94.5. Here's all of the different categories. Now we're going to put in the frequencies into list 2. So 6 in the first class, 6 in the second class, 5, 6, and 17. So what happens when we calculate the mean and the standard deviation? Since there's 6 in the first category, it's going to calculate that value 6 times. and so on. So we're going to go stats, arrow to calc, hit enter for 1-bar stats. This time we have our list in L1 and our frequency list goes into L2, or is L2, so we're going to hit second and the number 2, arrow to calculate and hit enter. On the very top we have our mean, which is 80, but it's only asking for the standard deviation. This is sample data, so we choose the S of X, which is 15.4 if we round it to 1 decimal. And that's our rounding rule. We always round to 1 extra decimal, so since we have whole numbers over here, we're going to round it to 1 decimal. So again, S of X is 15.4 when we round it to 1 decimal. All right, number 27. Use the range rule of thumb to estimate the standard deviation. Round the results to the nearest tenth. Okay, the range rule of thumb says that the standard deviation is approximately the range divided by 4. So we have to first find the range, and again the range is the maximum minus the minimum. So let's find the largest value, which is 6.2, and the lowest number is, looks like it's 5.4. So the range is equal to 6.2 minus 5.4, which is 0.8. And that means our standard deviation is approximately the range divided by 4, which is approximately equal to 0.2. So using the range rule of thumb, we can say that our data set has a standard deviation of approximately 0.2. Number 28. So this time we use the empirical rule, which is the 68, 95, 99.7 rule. So I don't have a lot of room over here, but I'm going to draw a little curve. I'm going to put the mean in the center. It says over here the amount of Jen's monthly phone bill is normally distributed with a mean of $59, so that goes right in the middle, and a standard deviation of $8. What percentage of her phone bill are between $35 and $83? So we're just going to make 3 equal divisions over here, because we know 99.7% of our data is within 3 standard deviations of the mean. So we take 59 and we add 8 to it, which is 67. So, and then we do 59, subtract 8, that's 51. And we're not where we want to be, so we know 68% of our data is within 51 and 67. So let's keep going. We're going to subtract 67, or add 67 plus 8, which is 75. And then we're going to go 51 minus 8, and that should be 43. So we have 43 to 75. Now we can say that 95% of our data is within, is between 43 and 75, but again, we're still not there. So we're going to do 75 plus 8, which is 83. And then we're going to do 43 minus 8, which is 35. So what percentage is within 3 standard deviation of the mean? Well, that's 99.7. So again, the rule is called 68, 95, 99.7 rule, because we have 68% within 1 standard deviation, 95% within 2 standard deviations, and 99.7% within 3 standard deviations. All right, the next question, number 29. It says, solve the problem, round results to the nearest hundredth. The mean height of basketball team is 6.3 feet with a standard deviation of 0.2 feet. The team center is 7 feet tall. Find the center's Z-score. Is his score unusual? So how do we find the Z-score? Well, the Z-score, we take our value x, we subtract the mean, and we divide by the standard deviation. So the mean is 6.3, and this person is 7 feet tall. So x is 7, and the mean is 6.3. The standard deviation is given to be 0.2. So we have 7 minus 6.3, which is 0.7 divided by 0.2, and 0.7 divided by 0.2 is equal to 3.5. So this person is significantly taller than the mean. In fact, he's 3.5 standard deviations above the mean. Is this unusual? Well, anything greater than 2 or less than -2 is considered unusual. So yes, this score is unusual because it is greater than 2. Okay, so we just have one more question over here on the back. This one we're asked to construct a box plot. Include the 5-number summary in all box plots. The weekly salaries in dollars of 24 randomly selected employees of a company are shown below. Construct a box plot for the data set. So we are using the 5-number summary. I'm just looking quickly through the list. It looks like it's ordered from smallest to greatest. So we can find our minimum and our maximum right here. The minimum is 310. The maximum is 3,700. And we can go through our list and just cross out from the outside until we find a midpoint. But instead we're going to use the calculator. So I'm going back to Stat and Edit. I'm going to put my data into list 1, so I have to clear it out first. So the first person is 310, 320, 450, 460, 470, 500, 520, 540, 580, 600, 650, 700, 710, 840, 870, 900, 1,000, 1,200, 1,250, 1,300, 1,400, 1,720, 2,500, and the last person 3,700. Okay. And an easy way to check to make sure you have the right number of people in there, you can check L1 of 24. So that means I have 24 data values in there. So I'm now going to go to Stat, Calc, 1-bar stats. Make sure you have just list 1 selected. There's no frequency list over here. And our 5-number summary is on the bottom over here. The minimum is, okay, how did I get, let's go back. Oh, I made a mistake down here. It looks like 600, I have 650. Okay, so it's always a good idea to check your numbers, but over here I entered 65 instead of my minimum, so let's just go through it real quickly. Looks like everything else is correct. So one way, when you're looking at your things, obviously check your answers, make sure that they make sense. So let's go back to Stat, Calc, 1-bar stats, list 1, no frequency list, and now I have a minimum of 310. I have a Q1 of 510, a median of 705, and a Q3 of 1,225, and my maximum is 3,700. Okay. All right, it's not asking over here for outliers, but I do want to go through the calculation of finding outliers as well. So let's check. Outliers, we have to first find the inner quartile range, which is Q3 minus Q1. Q3 is 1225, Q1 is 510. So that is 715. Now we're going to do Q3 plus 1.5 times the inner quartile range. So that is 1,225 plus 1.5 times 715. And that would be 2,297.5. Then we do the same thing with Q1. We're going to subtract 1.5 times the inner quartile range. So that would be 510 minus 1.5 times 715. And that's going to be a negative number. So there's going to be no outliers on that side. But let's see if there's values that are greater than 2,297.5. And in fact, it looks like we have two outliers over here. So 2,500 and 3,700 are both outliers. So I'm going to actually graph a modified box plot. A modified box plot has the outliers indicated as an asterisk or a point. All right, so the first thing we want to do is draw a scale, and our numbers are quite big over here, going from 300 to 3,000. So let's start with 300 over here, and then let's say 400, 500, 600, 700, 800, 900, and 1,000. And then we have 1,100, 1,200, 300, 400, 500. So here's 1,500, 16, 17, 18, 19, 2,000, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37. So you have to make your scale small enough to fit over here. Our minimum starts at 310, so this is where our whisker starts. Our Q1 starts at 510, so this is where our box starts. Our box goes from Q1 to Q3. So Q3 is at 1,200. So this was 1,000. So 1,225. Just above that over here, we have our box. And then it goes to the maximum. So if we have a modified box plot, we're going to end the whisker at 1,720. So 1,500, 1,720. And then we indicate the two outliers as a dot or an asterisk over here. And then the last thing, we need to draw a line for the median. So again, that's 4, 5, 6, 700 over here. Here's our median. So this data looks like it's right skewed over here. If we drew a regular box plot, I'm just going to draw this right on top of it. Everything here so far looks the same. Our whisker, our Q1, median, Q3. But this time we have a whisker that's extended all the way to our maximum. So this one is a regular box plot. And this one is a modified box plot. So since we've put our data into the calculator, I also want to graph it over here. So what we do is we're going to go to second step plot. We are going to make sure that only the first plot is turned on. So let's go to plot 2 and turn it off. Then let's go to plot 3 and also turn it off. And now it looks like only plot 1 is turned on. So we want a modified box plot over here. We want L1, and then we want a frequency of 1. You can't actually clear out this frequency over here, so just put a frequency of 1. Now we're going to graph it right here, and we're going to do the stat zoom. So if you go into zoom and click 9, it zooms into the stats zoom. You can also trace it. It will show you the different points. Over here is the minimum, Q1, max, median, Q3, the largest value that's not an outlier, and then the 2 outliers over here. Let's go back. If you had to do a regular one, we would go back to second y equals, turn on the first one, and this time instead of choosing the modified box plot, you're going to choose the next box plot. List is L1, frequency is 1, you hit graph, and over here is our regular box plot. And let's see if we can just trace. We can trace over here. Sometimes you have to do the zoom 9 first before you can trace. You can see all the points. So the only difference is the outliers on the modified box plots are marked as asterisks, and you have to make sure you end the whisker at the largest value that's not an outlier. All right. I hope this explains all the missing questions, and I will see you in class.